In this problem, we have a medicine ball being thrown against a wall and rebounding back with a new velocity. The problem asks for the impulse on the medicine ball. If you recall, impulse, J, is equal to the change in momentum of the object. In this case, we want the impulse on the ball, and it's going to have a change in momentum. Let's draw a picture. Here's the medicine ball. It's going to collide with a wall, moving with a velocity of 5.9 meters per second. Later, that medicine ball is going to rebound off the wall to the left at 2.8 meters per second. We have a mass of the medicine ball of 5 kilograms. That's going to remain the same. And we want to know the change in momentum of that medicine ball. Let's look at that equation and dig a little bit deeper. Well, change in momentum would be the final momentum of the ball minus the initial momentum of the ball. And so if I can figure out what those momentums are, I can subtract them and get the total impulse on it. Let's start defining some of the things we know. We would know that since momentum is equal to m times v, then I can write this as the mass times the final velocity minus the mass times the initial velocity. So really, that's what's going to get us our impulse. Well, we know the mass is 5 kilograms. The initial velocity of the ball, I drew arrows here, right? Velocities are vector quantities. Well, I drew a right arrow, so I'm going to call that positive 5.9. meters per second. And it's not a bad idea on my picture to indicate that I've drawn it such that to the right is positive, which makes our final velocity a negative value. That's a common place where you're going to see mistakes. Well, now let's plug in and figure out what our impulse is. Well, we would have 5 kilograms times the final velocity, which is actually negative 2.8 meters per second, minus the same 5 kilograms times the initial velocity, positive 5.9. And when you do this, you end up with a negative value minus another negative. Let's evaluate each piece. 5 times 2.8 would be negative 14 is the momentum after, minus 5 times 5.9, 29.5. All right, this is what J, or the impulse, would be. And so we end up getting an answer to suggest that the impulse is a negative value. Right? We have 14 and 29.5, negative 43.5. Impulse is the same units of momentum, that'd be kilogram meter per second, as the change in momentum. Right? And let's think about what that means. That says that it experienced an impulse to the left. Well, the impulse is caused by the wall. The wall is what pushed on that ball over a period of time to change its momentum. So that makes a lot of sense, right? The wall was to the right of the ball. It was pushing to the left in order to change that object's momentum. It slowed it to 0 and then added 2.8 in the other direction. So there was a big velocity change, and we see that with these two velocities effectively being added together to get a big velocity change. Anytime you see an object change direction, that's going to be a very big velocity change as compared to just stopping it or slowing it down. So this is a good example where you got to watch out for the signs. Now, another thing to be careful. Well, what do they want as an answer? I have my impulse as being negative 43.5. But what if I drew the wall on the left and had the ball starting going to the left? I might call that the positive direction, in which case, or I might call that the negative direction, in which case I could have an impulse that's positive. So depending on how I drew the picture, I actually could get a positive or a negative because the problem doesn't indicate it, which is why that problem asks for the magnitude of the impulse. When they want the magnitude of the impulse, that's another way of saying the absolute value of the impulse. So, or how much impulse. There are 43.5 kilogram meters per second of total impulse. Magnitude is just the amount. They do not want the direction in the answer. So even though, as I've drawn it with normal convention, with positive being to the right, and I threw the ball to the right, my number suggests that the impulse is left and is negative, but the answer needs to be a positive number because they're only asking for the magnitude of the impulse. So be careful anytime a problem asks for magnitude as an answer.